Hello, everyone. I'm Frank, and welcome to Frank Puzzles. And this is today's challenging level puzzle. And it's called Common Ground by Sudoku. And here are the rules. We have normal Sudoku rules applied. That is, each row, column, and designated 9 and 3 by 3 region has to contain the digits from 1 to 9 once each. We have killer cages, where digits in a cage do not repeat and must sum to the clue in the top left. So, for example, you could not have something like, say, 9, 9, and 4 here, because there are repeats in this cage, even though this adds up to 22, which would be valid. So that's not valid here. We could have, if this were, say, 4, this would have to be 7 here, because these two digits must add up to 11, because they are the digits in the cage, which has an 11 in the upper left-hand corner. And those are all the rules. Very simple killer cage Sudoku. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, these digits are the digits 1 through 5, adding up to 15. These are the digits 5 through 9, adding up to 35. These are the digits 1 through 5, adding up to 8. These are the digits 1 through 5, adding up to 8. To add up to 6, it's 1, 5, or 2, 4 here. And we have in this cell, at least, well, there's going to be one digit from 1 through 4 and one from 6 through 9 to add up to 10, right? You either 1, 9, 2, 8, 3, 7, or 4, 6 adding up to 10, which means in the rest of this box we have 4 digits here from 1 through 5 and 2 digits here from 1 through 4, which means the rest of the box cannot be 1 through 5 because we have 5 digits already, 5 cells, I should say, which must contain the digits 1 through 5 in that box. So we have a 5 either here or here. What else do we have? This is 1 through 5. This is 5 through 9. So we have a guaranteed 1 here. We have a guaranteed 1 here to add up to 8. This is 5 through 9. So we have a guaranteed 5 or 9 here. And a guaranteed 9 here to add up to 22. Okay. This has to be 4, 9, 5, 8, or 6, 7, adding up to 13. We have a guaranteed 9 here again, so this cannot be 9, which means this can't be 4 here. 9 in box 4 cannot be here again because 9 is guaranteed there, so it has to be one of these 3. How does this work? So all of these are 9, which means this cannot be 9 here. So this could be 1 through 8 there. To add up to 18, what are the possible combinations? It's either you could have 1, 8, 9, 2, 7, 9, 3, 6, 9, or 3, 7, 8, 4, 5, 9, or 4, 6, 8. So the key here, though, is that you have 4 digits in column 5, which have to be from 5 through 9. That means we can only have 1 digit here from 5 through 9. And we know all the combinations that add up to 18 189, 279, 369, 378, 459, and 468. Oh, there's still some other ones too. 567 is the last one. All of them require 2 digits from 5 through 9 at least. 567 doesn't work because again, I was thinking about this advanced in ahead of time, which is why I was like, well, only one of them here can be from 5 through 9. That means you have to have a 5 through 9 here, and then a digit from 1 through 4 here. So this cannot be, we are guaranteed for 5, so it cannot be 5, 6, 7. So the possible combinations are 1, 8, 9. So in that case, it would be 1, 8 here, and 9, because none of these can be 9 because they see the 9 in this cage. 2, 7, 9, so it's the same issue there. 3, 6, 9, same there. 3, 7, 8 is possible, so this could be 7, 8, and 3. 4, 5, 9. So that would be 4, 5, and 9, or 4, 6, 8. And so, none of these can be 5 here then. The only way this has a 5 is you can't. It's 4, 5, and 9, right? And the 9 would have to be there. So that means 5 in the 5, 6, 7, 8, 9 quadruple or quintuplet. We are definitely having 4 there, and one of them has to be here. Which means we can eliminate 5 through 9 in the rest of the column. So this has to be 2, 3, or 4 here. Interesting. What does that mean? That means if this is 1, 3, 4, this is guaranteed to be a 2. So one of these 4 digits is a 2, which eliminates 2 in the rest of the row. So this can't be 1 or 2. This has to be 3 through 9 here. Okay. To add up to 11, it has to be 2 through 8 there. Right, so these are low in 5. So we have to have a 5 in one of these 3. Okay, so these cannot be 5. These are high. This is low or 5, and we have a guaranteed 5 in one of those cells. So this cannot be 5 here. There's no 5 here. So this cannot be 8, because that would force this to be 5, 9, but we can't have a 5 there. So this can't be 8. These are all high. So we're guaranteed a high here, guaranteed high. These are high or 5, and we know there's a 5 here, so this cannot be 5 here. So these are high. These are high or 5. We have 1 low, 1 high here, and this is low. These are low or 5. These are low or 5. These are high or 5. These are high. This is high or 5. Hmm. What does this mean? I'm not really sure. This is high and 5. Oh, sorry, high and low. Guaranteed. The interesting thing is, if this is 679, where is 679 in box 4? It obviously can't be here, so all of these would have to be 679. Oh, where is 1? Where is 1 in column 1? Can't be here because of the 125 triplet here. So it has to be here, which means this can never have a 1 here. Which means to add up to 12, it's at most, it has to be at minimum 2, 3 with 7. So this can never have a 9. So this has to be 2 through 7 there, because you can't have a 1 here, because of 1 in the box being in the 8 cage. And since you can't have a 1 here, you can't have a 1 here, 1 has to be here, which means this can't be 1 either. So we're guaranteed a 9 here, which means this can't be 9. So 9 has to be one of these two cells. Interesting. If we had, so if this is 1, 5, none of the rest of the box can contain a 1. If this is not 1, 5, it's 2, 4. And then this is 5. That seems okay. This could be 3, 4, and 5 here. Interesting. Where are these 3 digits? So say we had a 1, 3, 4 here. Where are, well, I guess, If this is 1, 3, 4, that means 1, 3, 4 cannot appear here, and they can't appear here. Where do they have to appear in column 1? They would have to be here. So this would be 1, 3, and this would be 4 here. If this is 1, 2, 5, where would 1, 2, and 5 appear in column 1? They would have to appear here for 1 and 2. So this is either 1, 2, or 1, 3 here. Whichever digit is with the 1 here has to be, cannot be here in column 1, can't be here in column 1, and can't be here in column 1. So it has to be there. Which means this cannot have both 2 and 3 either in this cage. Whichever 1 or 2 is, whichever 2 or 3 is here cannot appear here in column 1. Where does it have to appear? It has to appear here, which means that doesn't appear in this cage at all. So, that means this can never have a 7 here. So it's either 2, 3, 2, 3, 7 doesn't work anymore. 2, 4, 6 does work, but that's the only one for 2. 3, 4, 5 works for this. So either way, one of these 3 is going to be a 4, which eliminates 4 in the rest of these cells here. Because if it were there, there's no way that it could be part of this. Where is the other 2 or 3? It has to then be one of these 3. Which means this can't be 2 or 3 here, guaranteed. So this can never be 3 here. So 1, 2, 5 is interesting. That forces this to be 3, 4, and 5 here. So if this is 1, 2, 5, this has to be 1, 2 as a pair. To add up to 12, you can't have 1 or 2. You have to be 3, 4, and 5. So if that's the case, this would be 3, this would be 4, and this would be 5. So if this is 1, 2, 5, it cannot be 5 here. Therefore, this is guaranteed to be 4, 5 there. If it's 1, 3, 4 here, this has to be 2, so this would be 1, 3 as a pair. Therefore, this would be 2, 6, and 4, but that doesn't work because if this is 1, 3, 4, where is the 4 going to be in column 1? It has to be here. But that 4 would eliminate the possibility of that being 4, so then this can't be 2, 6, 4. So this cannot be 1, 3, 4, it's 1, 2, 5, which means this must be 3, this has to be a 1, 2 pair here. This then has to be 3, 4, and 5 to add up to 12, which means this can't be 3 or 4. It's 1, 2, and 5 here. So this is 5, which is not low. That's pink, no pink here, no pink here. So this cannot be 1 or 2 because of the 1, 2 in the column. These can't be 5 anymore because if this is 1, 2, 5, that has to be the 5. So this is not pink either. So we have 5 here, which means this can't be pink. Therefore, this must be pink here as the 5. So no 5 here. This is a 5. Where is 4 in column 1? Can't be any of these cells, can't be here, so this must be 4 here. Where is 5 in all of column 1? Can't be here because of 5 in the box, so this must be 5 here. So this is 5, 8, and 9, which means this cannot be 5 here. So this is 1, 3, and 4 here. Which means eliminates 1, 3, 4 in the rest of the row, so this can't be 1, 3, 4, it's 2. That means there's no 3 or 4 here, which means this is 5 through 9 here. So this cannot be 7 or 8 here to correspond to the 11. That leaves the remaining digits in column 1 as 6 and 7, and the remaining digits in this box then as 8 and 9, which are all high. So we have all the highs accounted for in row 6, which means the rest are low. So these are low. This 3, 4 eliminates 3 and 4 here, and 3 and 4 here. This is 2, so this can't be 2, which makes that a 1, which eliminates 1 in the rest of the cage. This 5 eliminates 5 in the rest of this row here. So this is a 2, 3, 4 triplet, which eliminates 2, 3, 4 in the rest of the cage and row. So this can't be 2, it's 5, which is not a low. This 2, 3, 4 eliminates 2 here. So that's 1, and therefore this must be 2. So we have 1 here and 2 here. This cannot be, where is the 5 in this cage? It has to be here, so this must be a 1, 5 pair. That means this has to be 2, 8, 3, 7, or 4, 6, with no 2 there, which means that can't be 8, no 4 here, which means that can't be 6. Where is 8 in box 1? Can't be here because of the 8, 9 pair in the column, so 8 has to be here. 9 eliminates 9 here. Oops, eliminates 9 here. The 8 eliminates 8 here. This can't be 8 because of the 8 in the row. So this cannot be a 2, 8 pair. Therefore, 2 in the box has to be one of these 2. Which means this cannot be 2 here. Remaining digits of column or box 1 are 3, 6, and 7. That eliminates 3, 6, and 7 in the rest of the column. So the remaining digits in column 3 are 1, 2, 4. Remaining digits in column 2 are 3, 4, and... Okay, can't be 4. This 4 eliminates 4 here, so that's 3, which means this can't be 3. Remaining digits then are 6 and 7, which are both high. And this is high or 5, so we have 5 digits in row 8, requiring high or 5 digits, which eliminates higher 5 digits in the rest of the row. So this can't be higher 5. This can't be higher 5. These are all low. Which means this cannot be 6, 7, or 8. This can't be 5 or 6, so this must be 2, 3, 4. To add up with 7, 8, 9 here. 1 and 5 are here. 1 is here. This can't be 1 or 2. So this must not be low. It's high there. So we can have 3, 6, 9, 3, 7, 8, or 4, 5, 9. So, or 4, 6, 8. Or 4, 6, 8. This is 1 through 4 here. These are low. This is 5. This is 4 as a low there. These are high. Okay. 5 eliminates 5 from here. So this is not pink. This can't be 5, so that's not 5. That's high, therefore. So the remaining digits in column 7 are all low. Interesting. We have 3 lows then in box 3, which means the 14 here cannot have 2 lows or more. It can only have 1 low at most. It must have a low, because to add up to 14, 5, 6, and 7 adds up to 18. So what are the possibilities with just 1 low? So that means the rest of this box cannot contain lows. So these have to be high or 5 here. Obviously 5 cannot be here because of 5 in this, 2, 3, 4 triplet eliminates 2, 3, 4 in the rest of the row. So this is not 3. Hmm. 2 eliminates 2 here. So where's 2 in box 2? It must be there. This can't be 1, 2, 3, 4, or 5, so this has to be a high digit, which is the last high digit remaining in column 6. So the rest is a 3, 4 pair, which are both lows. And since this is a 3, 4 pair, that eliminates 3 and 4 in the rest of the box in box 8. This can't be 3 or 4, it's 1. That leaves that as 4, so no 4 here. That leaves this as a high or 5 in box 8. Okay. So this is 1. Okay. 2 cannot be here. So 2 has to be one of these 3 digits. To add up to 14 with 1 low, you could have 2 highs. 1, 6, and 7. 2, 5, and 7. 2. That's it. 1, 6, 7. Without 2 lows. It's just 1, 6, 7 there. 1, 5, 8 also works. So 1, 5, 8, 1, 6, 7, 2, 6, 2, 5, 7, 3, 5, and 6. So what you cannot have, though, is a 4 in any of those combinations. So you could have 1, 5, 8, 1, 6, 7. So no 8 here, though. 2, 5, 7, or 3, 5, 6. You cannot have a 4 here. So 4 is guaranteed to be in one of these lows, which means this can't be 4. It's 1, 2, or 3. This is 2, 3, or 4 here. We have 5 there. This is definitely high. This is higher 5. Huh. Okay. This cannot have a 5 anymore, therefore it's 6, 7, and 9 as a combination. Which means this can't be 6 or 7 or 9 because all three of these digits see this one. So it cannot be 3, 6, 9 anymore. What can it be? It could be 3, 8, 7 there. This has to have a 9 here, so this cannot be 9 here, so it's 6 or 7. So where's 8 in column 6? It must be one of these two, which means this can't be 8 here in the rest of the box. Again, we could have 3, 7, 8 now. You cannot have 3, 6, 9 anymore. You could have 4, 5, 9, or 4, 6, 8. We have a 6, 7, 9 triplet in column 5, which eliminates 6, 7, 9 in the rest of the column. So this can't be 6 or 7, it's 8. Which means we cannot have an 8 here, which means we cannot have 5 and 8 as combinations. You could have 5 and 7, though. 2, 5, 7. So this is either 1, 6, 7, 2, 5, 7, or 2, 5, 6. Interesting. 6 through 9 here. Eight cannot be here. 8 in row 3 must be one of these two cells. Okay. Remaining of the digits in box 5 are 2, 3, 4, 6, 7, 9. This can't be 3 or 4 because of 3, 4 in the row. So one of these two is a 9. I don't know how much that helps. So 1, 6, 7, 2, 5, 7, or 3, 5, 6 add up to 14. So whichever digit is here has to be here, I guess. This can't be 4 because of 4 in the row. This has to be 1, 2, or 3 here. This is 1, 3, or 4 there. Okay. What else do we know? This has to be 2, 6, 7, 8, 9 as possible combinations. Okay, so again, 3, 7, 8 works. 4, 5, 9. So if this is 3, 7, 8, this becomes 6 and 9, which would force this to be 5. Oh, we have a 6, 7, 9 triplet in row 8, which eliminates 6, 7, 9 in the rest of the row. So guaranteed 9 is one of those two. So again, 3, 7, 8 forces that to be 5. 4, 5, 9 forces this to be a 6, 7 pair, and that's 8. Oh, this is a 6, 7, 9 triplet. Okay. That doesn't help too much, though. Interesting. We have 1 through 4 here. Okay, let's try to figure out these relationships here. So we have A here. The other 3 or 4 here is B. So then this must be B, this must be A, this must be B. So A has to be one of these 3, cannot be here, so A is one of those 2. This is A, so that makes that B. B is here and B is here, so B has to be at least one of those 2. B is here, B is here, so this cannot be B, so B has to be one of these 2 here. Okay. A is here, so cannot be here, so A is one of these 2. That's interesting. So this can't be A and cannot be B, so this cannot be 3. Therefore, 3 is guaranteed to be one of these 3. This can't be B, so A has to be one of these 2. And since A and B are here, this cannot be 3. So it has to be either 1, 5, 7, or, sorry, 1, 6, 7, or 2, 5, 7, which eliminates 7 in the rest of the box. If it's 1, 5, 7, this cannot be both 1 and 5. So this would have to be, well, sorry, it's 1, 6, 7. Well, if it's 1, 6, 7, you cannot have both the 6, 7s here, because that would eliminate all possibilities for, or 2 of the 3 possibilities for these 2 cells, which means they would both be the same digit. So 1 would have to be here. Which means that can't be 1. So if it's 1, 6, 7, you have 1, 6, 7 here. If it's 2, 5, 7, we don't know how. The 2 has to be one of these 2, but we don't know. So this has to be high or 5. This is, oops. This cannot be 7, so it's 5, 6, and 9 as possibilities. Okay. Um. This digit could still appear here or here, right? Hmm. Hmm. Um, Not too helpful. Um, these two digits are the same as these two digits here. Um, oh, this digit must be the same as one of these two digits here because it can't appear here. That's why we have an 8 here. Okay, so this digit cannot appear here. It has to be one of these two digits here, which means if it were... So if this did... Okay, in column 6, where is that digit? Can't be here because it's in the cage as those two. So it has to be one of these two. Which means in box 5, it cannot appear in the rest of this box because it has to be one of these two. Well, this digit can't appear here in this box, in this cage here. So where is it in this cage? It must be here. So this cannot be 8, which means this has to be 8 here, which makes this 9, that 8. That eliminates 8 and 9 in the rest of the row. So this has to be an 8 here, which means this cannot be 8 there. We have 2, 6, and 7 here. You have a 6, 7, 9 triplet in row 6, which eliminates 6, 7, 9 in the rest of the row. This can't be 6, 7, or 9, it's 8, which means this can't be 8. We are guaranteed a 9 here, so this cannot be 9. So we know where is the 9 in column 7. It must be one of these two cells, which eliminates 9 in the rest of the box, so this cannot be 9, which means this can't be 2, so this is a 3, 4, which must be the A. So this is 3, 4 as A. That means this can't be 3, 4 because B has to be there. So this is 1, 2 here, 1, 2 here. B is one of these two here. This is 7 or 8. So this digit must be the same as that. We'll mark that as a Z. These two digits must be the same as the two digits that are here. This digit has to be the same as that, so this is Z, which is the same as one of these three. Ew. These two are the same as these two. So that's not too helpful either. We know this is Z. This could be Z, this could be Z. Oh, we have a 6, 7 pair in row 5, which eliminates 6, 7 in the rest of the row, so there's no 6, 7 here. This digit cannot be the same as that. Let's remove the reds and blues. Maybe we can get something easier with just coloring and the pinks. So A, we'll mark that here. B will mark as pink. Therefore, this is yellow. This is yellow. B has to be one of these two. B has to be one of those two. This is B. A is one of these two. B is here. B is here. What about these? So we'll make this green and red. So this must be red here, which means neither of those are red. These both have to be, one of them has to be green and one is 9, which means this cannot be 9 here. This is 2, 3, 4 as a triplet. Therefore, this can't be 2, 3, or 4. It's 6 or 7 and is the red 6 or 7. This is also 6 or 7. So this can't be 6 or 7 here. It's definitely 9, which eliminates 9 from being here. 9 eliminates 9 from being here. So this is a 6-8 pair, which eliminates 6 and 8 in the rest of the row. This can't be 6. It's 7. There's no 7 here. It's 3 or 6. This 6-8 pair eliminates 6, 1, 6, and 7 as a triplet here. So this has to be 2, 5, and 7 here, which eliminates 2, 5, and 7 in the rest of the box. This can't be 5. It's 9. This can't be 2 because of the 2, 5, 7 triplet in the box. Remove all the A's, remove all the B's. One of these is 9, so we have red, red, red. That means green has to be the 3 or 6 or 7 there. This is red, so one of these is green. This is not green here, so this must be red, which means green has to be one of these two. We don't know about this, though. This can't be 1, so that makes this 2, which makes this 1. 2 eliminates 2 here, so that's 1 and 2. So pink and green add up to 10, which means yellow and red add up to 10. Red is here. So red could be still here or here. Red is one of these two in column 6. Red is one of these two. Green is obviously still one of those 3. We have 2 guaranteed here, 2 guaranteed to be here. This can't be 2 anymore. This can't be 1 because of 1 in the column. Yellow can't be here, so yellow's one of these 2. Yellow's also one of these 2. So this cannot... So we are guaranteed a 2 here. This is 3 or 4 as yellow. So red cannot be here because yellow and red add up to 10. So therefore they can't add up to 11. So red has to be one of these 3 here. Okay. We don't know what this is. So one of these 3 is green. We don't know which. Oh, can this ever be green? Pink and green add up to 10. So if this is pink and green, this has to be 8. Otherwise, this can't be green. That could still certainly be the case. Otherwise, this would be... So this is either a green 6, 7, or it's 9, right? Hmm. Ugh. Okay, so this cannot be 2. 1 is definitely one of these two. Okay. We have a 2, 6, 7 triplet in box 6, so that eliminates 2, 6, and 7 in the rest of the box. So we need a 9. Where is the 9 in box 6? Can't be here because of 9 in the column. Can't be here because one of these two is a 9. So therefore, this must be 9 here. Where is the 1? 1 has to be here, which means this cannot be pink. This has to be pink here, which means this is yellow here. This can't be yellow. So this is yellow here. That makes this a 2, which makes this 1, which makes that 2. Obviously, this can't be pink here, which means where's pink in box 9? It has to be here. That means red has to be one of these two digits here. Okay, red cannot be here, red cannot be here, so red is one of these two digits here. We need green. Still don't know where green is. This is 3, 4 as a pair. This can be 5 through 9 here. Cannot be 9 here because of 9 in the column. Okay. If yellow is 4, this would have to be 7. But we are guaranteed, so green has to be 7. So 4 and 6 would then be here. Green would be 7, but green can only be here. So yellow cannot be 4, therefore yellow has to be 3. Oops. We'll move that. So yellow has to be 3. That makes this 8. That makes this a 4, 6 pair, which means this is not green. It's pink. This is not pink. It's green. So the pinks are 4. That means reds are 7. So this is not reds. This is not red. This must be red here. One of these is red here. This can't be 6, so it's a 5, 7 pair, which eliminates 5 and 7 in the rest of the box. So there's no 7 here. We don't know which ones of these are red. So these all must be 7, which means this can't be 7, that's 5. This can't be 5 or 7, it's 2. There's no 2 or 7 here, so it's 6, which means this can't be 6 or 7, it's 2. 8 eliminates 8 here, so that's 6 and 8. This is 4, which is 4, 5, 9, or 4, 6, 8. So this cannot be 7. We already knew that, though. This is 5, 7 as a pair. 8 eliminates 8 here. So these are the same. This must be a 6 here. This can't be 4 because of 4 in the column. 5 eliminates 5 here, so that's 1 and 5. 1 eliminates 1 here, so it's 3 and 1. 3 eliminates 3 here, so it's 6 and 3. These two are the same, which is the same as that. Which must be the same as here. So it has to be 9. So Z's are 9. So these are all the same, which means these are all 9, which makes that not 9. It's 6, which makes that not 6. It's 7. No 6 or 9 here. It's 7. This is 4 and 9, which makes that a 5, which makes that 8. 5 eliminates 5 here, so that's 8. This can't be 8 or 9. It's 5. 7, this can't be, this is 7. This can't be 7. It's 6. I don't know how I got that. 6 eliminates 6 here, so it's 7 and 6. 9 eliminates 9 here, so it's 6. 5 eliminates 5 here, so it's 7, which makes this a 5. And that's how you solve it. Kind of tricky, actually, at the end with the way that that was set up. Was interesting how that worked for the way that these 6-7 pairs and 3-4 pairs worked. So, yeah, overall pretty interesting puzzle with just killer Sudoku. I did not find this that easy to do. It had some interesting not assumptions, but what were the deductions, I guess, that came about. Yeah, overall just a pretty fun puzzle though. It was an interesting. The Killer Cage Sudoku wasn't the be all and end all of this puzzle, really. There was a lot of interesting interactions between these cages and the 3-4s and the 6-7s specifically. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.